OrCAD's real-time, customizable, and modern interface is reinventing the electronic design journey so that you can be successful in all your projects. It's easy to set up real-time design rule checks to notify you of issues that occur as you design. You can immediately jump to the issue on the canvas by clicking on any of the warnings or errors listed and easily ensure that all issues get resolved. The integrated parts search and placement lets you quickly find the perfect part so you can focus on designing instead of navigating distributor websites and manually comparing component data. You can quickly view datasheets, models, parametric data, and more. And with a single click, you can easily place the part you've selected on your schematic and keep designing. Then simply simulate your design in a virtual environment to quickly validate circuit behavior and performance. Design synchronization makes it easy to quickly review if your design is ready for layout and helps keep the data between your design environments in check. The intuitive board layout and routing tools in OrCAD ensure you're productive through the entire project. Component placement is an important factor in optimizing performance, and dynamic propagation delay checks help you design an organized and efficient board with fewer late-stage changes. You can rely on OrCAD to help you get your designs done faster thanks to the industry-leading interactive routing engine. An electrically aware heads-up display shows the exact status of your constraint-driven design goals at a glance. And similarly, manufacturing checks help you identify and resolve defects issues quickly so your design doesn't cost you time and money. You can even improve your design by turning on 9 different routing rule checks. Color-coded notifications help you quickly and easily identify and resolve the traces that don't match your rules. Then with the integrated analysis tools, you can leverage live simulation data to identify and resolve critical design issues. Here again, easy to understand color-coded graphics help visualize SI issues on your board. And when it's time for design sign-off, help your manufacturer understand your design intent by providing accurate fabrication and assembly documentation to convey everything needed for error-free manufacturing. OrCAD's customizable and easy-to-use modern interface and real-time insights help you make informed decisions while you design. While you may have time constraints or a limited budget, going straight from design to production is not a good idea. With prototyping, you can quickly validate your ideas and avoid any unanticipated issues or extra costs later in your design process. Prototyping with reuse in mind allows you to explore various design configurations with confidence, as you can easily reuse constraints or blocks of known good circuits from previous designs. To speed up the design process, we've reused the RF amplifier circuit to complete our digital synthesizer. Simulating and validating the behavior of your circuits with PSpice gives you the flexibility to virtually create and test various designs before any hardware is developed, saving time as well as cost. And as you move on to the layout, it's easy to reuse and apply any necessary design constraints so you can rapidly prototype your designs. Real-time visual feedback helps you quickly find potential defects or functionality issues. With OrCAD, it's easy to turn your ideas into successful products faster. Creating a reliable and functional schematic is no easy feat, so it's important to define your electrical connectivity as well as understand and analyze the behavior of your circuit to identify and avoid any possible field failures. By applying design rules within your OrCAD schematic, it's easy to communicate your design intent with the PCB Designer and eliminate unnecessary iterations. Once your rules are set and your connections are completed, it's easy to simulate your design using PSpice and take advantage of its advanced analysis capabilities. The flexibility of creating and testing your designs in a virtual environment helps you save time, money, and materials. Here, sensitivity analysis helps identify the critical components in your design. This way, you can easily save design costs by loosening the tolerance on the non-critical components without risking your circuit. And if you have multiple revisions of your schematic, it's easy to compare the differences between your designs side by side. You can quickly review these differences in an interactive HTML and share the report with your extended team or even non-designers alike. And if you need different configurations of the same design, it's easy to create and manage variants from a centralized location. You can quickly generate different BOMs required, helping you meet time to market and save costs. With OrCAD, easily identify, analyze, and review your schematics to ensure design reliability. Manufacturing problems can disrupt your project's timeline and budget. The earlier you can solve them, the better. With a wide range of fabrication, assembly, and testing checks available in OrCAD, you can ensure that your design meets quality and reliability standards. With OrCAD, it's easy to create and assign manufacturing rules to your design. Just find the constraint set and create a new rule. Then choose where to apply the rule in your design from the design section. Here, we've set up and assigned a rule to look for problematic solder mask dams on fine pitch devices. With real-time DFM checks, you can easily spot and fix violations that may have otherwise gone unnoticed. Now that you have a clean design, you can start to document your design data. The documentation editor in OrCAD makes it easy to document your fabrication and assembly details. The information is automatically generated using the CAD data from your files, ensuring accuracy and reducing room for manual mistakes. And when your documentation is ready, IPC 2581 allows you to combine all necessary PCB manufacturing data into a single file. This way, you can easily communicate your design intent to your manufacturer and get your design manufactured accurately. With OrCAD, you can easily ensure the manufacturability of your designs with real-time visual feedback and avoid field. Designing for high speed is extra challenging because every decision you make can affect the signal integrity of your design. So how do you efficiently manage SI issues to maximize performance and functionality? Routing for high speed requires precise spacing, length, and timing constraints to be met. If your differential pairs have a length mismatch, it could result in poor performance and weak functionality. The dynamic differential phase control in OrCAD highlights any traces in violation and simultaneously helps verify that your differential pairs match in length and meet your phase constraints. And let's not forget the Z-axis length when signals travel up and down through vias between layers. The Constraint Manager can help you analyze your match groups and identify traces that need length tuning. They're the columns highlighted in red. And as you adjust your traces, real-time visual feedback in a heads-up display helps you make sure that you properly manage signal integrity. The integrated analysis workflows in OrCAD, powered by Sigrity technology, helps you easily analyze, identify, and resolve real SI problems in your design. Here, a split in the plane is causing an impedance discontinuity. Easily adjust the planes to fix the issue and run the analysis again to see the results. But some things aren't as easy to fix within your layout, which is why you may need to use some advanced manufacturing techniques, such as backdrilling and HDI. With backdrilling, your manufacturer can remove the steps to help limit reflection and impedance differences. Making smart decisions to meet cost, reliability, time to market, and yield are all key pieces of creating a good design. OrCAD allows you to easily identify critical and non-critical components so that you can improve your circuit's performance and reduce design costs at the same time. Running sensitivity analysis on the RF amplifier lists all your components by order of importance from most critical to least critical, allowing you to set strict or loose tolerance limits. Here, the simulation shows us that the bandwidth, output noise, and gain are the most dependent on components R4, R8, and R6. Since we've identified the critical components, we can easily send them to the discrete engine of the PSpice optimizer to fine-tune the circuit for better performance. Running the analysis gives us new values for the 3 resistors based on our design goals. We can easily update our circuit and re-simulate the design. With our circuit adjusted, running smoke analysis helps identify components that are likely to fail in the future. The green bar tells us if the components are within safe operating limits. We can see that component Q1 is being pushed to its limits. We can either replace Q1 or adjust our design. Let's replace the component and rerun the analysis. And finally, how would you predict the manufacturing yield of your design and avoid costly failures? With OrCAD, it's easy. Just run the Monte Carlo analysis based on your design goals to quickly evaluate if tighter component tolerances are better for your designs. With the PSpice suite of advanced analysis tools, OrCAD makes it easy to reduce design cost, improve your circuit's reliability, and improve manufacturing yield. You've probably seen thousands of schematics or board designs that have the same technology. That's because important circuits are used more than once, in and between designs. Design reuse is an efficient way to get to market faster with known good circuitry. But design reuse isn't just about circuitry. You can reuse all kinds of IP. Hierarchical design makes it easy to reuse blocks of known good circuits from other designs so you can quickly define individual circuits at a higher level. And instead of manually creating new rules, it's easy to import and apply an existing set of validated constraints. This way, you can ensure that your electrical requirements can be met. Reusing proven constraints in circuitry within your schematic or even layout is a quick and easy way to speed up your design process. For example, lots of designs use DDR memory, so there's no reason to redesign a new memory bank every time. Here, we're applying a module that was created on a 14-layer board, and our current design is an 18-layer board. Since we're working with managed reuse modules, we can easily map the stack up to the layers on our current board. With OrCAD, it's easy to reuse past designs to ensure productivity, minimize design errors, and get to market with verified technology faster. Designing for high-risk applications such as automotive, military, or aerospace doesn't leave room for field failures. By creating a functional and reliable design, you can minimize safety risks while maximizing uptime. OrCAD is ISO 26262 certified and can help you identify and prevent failures early on. Since the overall reliability of your design is determined by individual components in your circuit, running PSpice advanced analysis such as sensitivity and smoke analysis makes it easy to find critical and stressed components. Here, we can see that capacitor C5 and C6 are being pushed too far. By finding the components within the design and making the necessary adjustments, whether it's tolerance or replacing the components, you can easily meet your design goals. As you work on the layout of your design, it's important that you run any necessary manufacturing checks to ensure higher quality and reliability of your product. Real-time visual feedback on fabrication, assembly, or even testing issues helps highlight any errors and can help you resolve them in a timely manner. With OrCAD, easily create reliable designs that have a long service life and work optimally right from the start. Whether your constraints are electrical, physical, mechanical, or manufacturing, they all help convey your design intent. But when they're not defined early on, you'll just prolong your design process and waste time and money. It's easy to create and apply design rules early in the schematic and transfer them to layout. You can simplify communication and reduce the risk for manual data entry mistakes. This way, you can eliminate unnecessary design iterations and improve time to market. When you've moved on to work on the layout, constraints help flag any issues within your design. You may see DRC markers within your design indicating that there's a conflict that you may need to resolve. It's also easy to filter through the organized list in case you want to focus on a particular error, like conductor violations. By setting your design parameters in the early stages, it's easy to shorten your design cycle and improve design quality at the same time. And if you want to look at the overall status, the DRC browser's interactive graph represents all of the errors in your design. With OrCAD, easily identify and fix potential problems to ensure the manufacturability of your design with a constraint-driven process. Automotive, medical, and IoT designs are complex and make a big impact on our lives. And because these complex systems are things we use on a daily basis, it's important to make sure that we analyze and identify any critical issues within our design to leave no room for errors. Simulation helps ensure that we're making robust designs. PSpice and MATLAB Simulink integrate so you can easily co-simulate an entire system-level design to achieve faster results in a less error-prone process. Here, part of the circuit is modeled in OrCAD, and I'll run a PSpice simulation to test if the circuit performs like it should. Once I'm satisfied with the results, I can easily integrate and configure the simulated PSpice circuit block with the input module in MATLAB Simulink with just a couple clicks. It's easy to connect and simulate diverse modules together, allowing us to simulate a complete system. The collaboration provides seamless bidirectional integration between these two industry-leading simulation tools. By importing a Simulink model into PSpice using code generation, or by bringing a PSpice model into Simulink using co-simulation, electrical circuits and mechanical, hydraulic, and thermal blocks can easily be simulated in one unified environment. With seamless bidirectional integration between OrCAD PSpice and MATLAB Simulink, you can easily catch errors in the design stage before they manifest in your prototype. Whether you're designing for mass production or a single board, having your design fail is not an option. Yield is one of the most important factors to consider when manufacturing so you can balance cost and profitability. But how do you quantify or predict the designs that may fail? The PSpice Monte Carlo analysis in OrCAD allows you to easily evaluate the manufacturing yield of your circuit so you can avoid costly failures. Let's first adjust the number of runs in our profile settings so that we get more accurate simulation results. Here, we see a probability density function graph of the yield distribution over the entire frequency range for the bandwidth of our circuit. Our design intent is to have the bandwidth of the RF amplifier be between 148 MHz and 160 MHz. But after running the simulation, it shows us that the yield of our design is only 68%. Since we're not willing to have 32% of our designs fail, OrCAD lets us easily tighten component tolerances on an individual, global, or even a sub-circuit level. For this example, we'll tighten the global resistor tolerance on the design from 10% to 5% and rerun the simulation. With the yield improving to 84%, let's tighten the resistor's global tolerance to 3% to try and get closer to 100% yield. With the PSpice Monte Carlo analysis in OrCAD, yield prediction can help you easily evaluate if tighter component tolerances will be better for your designs. Manually maintaining manufacturing files like Gerber, drill files, netlist, and more is bound to lead to mistakes. IPC 2581 combines all necessary PCB manufacturing data into a single file so you can easily communicate your design intent to your manufacturer and get your design manufactured accurately. With default configurations and presets, you can easily select from a list of fabrication, assembly, or custom outputs to fit both you and your fabricator's needs. And for user-defined layers, the layer mapper can help you express your manufacturing intent. Here, we can map layer sets to the 5 different output types available, make any changes necessary, and hit OK. By using the IPC 2581 manufacturing data format, you can accurately convey design intent to your manufacturer and improve time to market. When your boards are large, dense, or both, it can get hard to find what you're looking for. The powerful Find by Query feature in OrCAD makes it easy to search within your designs. Building your query is easy. Rather than typing your query or memorizing functions, you can browse through all available object types and drag and drop. Just specify the operator values and instantly filter objects by their properties. Your results are displayed instantly, and you can narrow your search by just dragging and dropping additional filters. Double-click on a result to highlight the object in your design. You can save your query and use it again later, helpful when you need to make bulk edits.
If you find that your impedance is off, you can easily change the trace width to match the design specification.
Load the saved query and apply it to an area of the board or the whole board. Now with the traces selected, you can quickly and easily change all of them.
The powerful Find by Query feature in OrCAD makes it easy to find what you're looking for and saves you time making bulk changes.
Design revisions are inevitable, and manually inspecting differences between your revised designs is a tedious and error-prone process. So how do you manage to keep track of the changes? With OrCAD, you can easily compare your design documents side by side. Browse for the designs that you want to compare, and you can filter by schematic in page 2. A summary is generated allowing you to view the differences in a logical and graphical format. Then easily view a comprehensive report which displays any differences between the schematics in a table. Clicking on an item in the table highlights the difference within the graphical view. And you can even sync the zoom level so that both schematics focus in the same spot at the same time. Here, the value of capacitor C2 was changed from 25 picofarads to 30 picofarads. Scroll through the table and quickly review the differences between the schematics, from component names, values, pins, wire connections, location changes, and more. And you can easily share this interactive HTML report with your extended team or non-designers too. With OrCAD, easily identify and review any differences between your designs to save time and improve productivity. Designing can be a breeze when you have a range of fabrication, assembly, and testing checks to ensure that your design doesn't need to cost you time and money during manufacturing. With a vast number of configurable checks and instantaneous visual feedback, it's easy to eliminate common issues before they become a problem. Like, for example, problematic solder mask dams on fine-pitch devices. These narrow dams leave you open to shorting issues and the possibility of your solder mask breaking. Mouse over the DRC marker to see more details about the rule violation in a heads-up display. Let's open up the pad stack editor and fix the issue. With real-time assembly checks, we can easily identify and eliminate potential soldering problems while designing. When creating a fan-out for this TSSOP, a DRC marker informs me that I've violated a rule. This via is a problem, but I can avoid any unnecessary tension on the component and resolve the error by choosing a different fan-out pattern. Adding a new rule is easy. Just find the constraint set and create a new rule. Then choose where to apply the rule in your design from the design section. Rules can be applied to conductor layers, solder masks, cover lays, and silk screens, or even non-layer specific, like board cutouts and aspect ratios. Now with the new rule set, we find component pin to other component body violations that might have otherwise gone unnoticed until much later in the design process. Real-time checks help you identify potential problems before you finish the design and before you begin the manufacturing process, helping you reduce costs and eliminate added expenses. With OrCAD, quickly and easily manage fabrication, assembly, and testing rules for manufacturing success.
Quick access to frequently used commands helps you be more productive when designing. The design workflow takes you through the typical steps of a design and puts the features you need right at your fingertips. As your designs get more complex or as you work in specialized teams, you can create custom workflows for specific tasks or roles, like library creation or quality control checks. You can also customize your toolbars and icons to make the tool fit your unique design needs. Enable and disable icons and rearrange the toolbars to suit your personal preferences. There are even icons on your right mouse button menu that can save you more travel time. OrCAD makes it easy for beginners and experts alike to be at their most productive when designing.
Catching coupling issues within your design before manufacturing will help you produce a more reliable product that performs well. The integrated analysis workflows in OrCAD, powered by Sigrity technology, helps you easily identify and resolve possible coupling problems without always having to rely on the SI expert. Easily filter and select the critical nets in your design to analyze coupling issues. A color-coded scale from red to blue quickly highlights any potential problems, and you can easily view the victim and aggressor nets in a table too. If there's a higher percentage of coupling, you're going to want to increase the spacing. Here, we'll focus on the USB 0 ID net and its aggressor. While these two traces are on different layers, there's no ground layer in between, which is why the signal overlap is causing coupling issues. Easily adjust the spacing between the traces and rerun the analysis to resolve the issue. With OrCAD, it's easy to manage the signals in your design and minimize or even eliminate possible coupling issues. Routing most boards takes up the bulk of your design time, and if you're working with flex circuitry or a uniquely shaped board, it could take even longer. So how do you quickly and efficiently route around the bends or corners? Drawing manual arcs is an option, but they're slow and less than precise. But with contour routing, you can easily draw multiple, uniform, and evenly spaced curved traces at any angle on flex circuitry, ensuring bendability and minimal stress on the edge. And if you're working with any high-speed or RF designs, contouring may not be necessary, but arc routing can help reduce both reflection and temperature rises. Removing angled traces that cause minor electrical losses help maintain good signal integrity. With OrCAD, you can confidently and accurately route through any design with ease, improving your productivity. Having your product fail in the field would be a nightmare, which is why testing should always be a critical part of your manufacturing process. Whether you're testing a bare board or a fully assembled board, it's important that you test both signals and components to avoid costly errors. With OrCAD, it's easy to set your design for test constraints. Just find the constraint set and create a new rule. Then choose where to apply the rule in your design from the design section. Being able to identify missing or obstructed test points is crucial so the signals don't go untested. Here, mousing over this DRC shows a rule violation for a test point covered in solder mask. Easily fix the issue by opening up your pad stack editor and adjusting your solder mask opening. Let's use the DRC browser to quickly find other DFT violations on our board. Clicking on the error takes you to that part on the canvas. Here, we see that a test point is located under a component. By moving the test point from under the component, the probes can access it and provide accurate test results. Quickly and easily manage your DFT constraints with real-time DFM technology in OrCAD for improved quality, reduced costs, and higher production yields.
We all run an assortment of validation checks before we sign off on a design. But there's no worse feeling than when you think your design is done, only to discover errors that you need to fix. Late-stage design changes can have a domino effect, making it almost feel like you're starting over. By running design for manufacturing checks in real time while you design, you can finally break out of the find, fix, reiterate cycle so you can get your design done right the first time. There are over 200 configurable checks always running in OrCAD while you design, giving you instantaneous visual feedback so you can eliminate manufacturability issues before they become a problem. Lots of manufacturability problems are hard to see in the design, like, for example, a trace going through a test point opening in the solder mask. When attempting to route a trace through the opening, you'll see a DRC error instantly highlighting the issue. Mouse over the DRC marker to see more details about the rule violation in a heads-up display. Check it out in 3D too to get a better look at the issue. By checking for DFM issues while you design in real time, you'll get your designs done faster and have less stress at sign-off.
OrCAD makes it easy to improve your circuit and identify possible cost-saving opportunities. By simulating your designs, you can find sourceable, stressed, and critical components to ensure a more reliable circuit. Once you've designed your circuit, it's easy to find actual parts that meet your theoretical component values. Just use the discrete engine of the PSpice optimizer to find component values that are commercially available. By picking the parts early yourself, you know you'll get the parts you need to make your design real. After selecting a component, you can stay up to date on availability right from the Part Manager window. You can also find key components and not so key components in your circuit. Sensitivity analysis will list all your components by order of importance to meet your circuit goals. You can easily save design costs by loosening the tolerance on those non-critical components without risking your circuit. And it's easy to improve the reliability of your designs using smoke analysis to identify components that are likely to fail in the field. The green bar tells you that the components are within the safe operating limits. You can either replace those components or adjust your design. The advanced PSpice analysis tools in OrCAD help you create reliable designs, improve your circuit performance, and reduce design costs at the same time.